So now let's talk about the process of how we might graph something like y equals tangent of 2x and how we're going to get this. The main thing that we have to know right here, of course, is what's going to happen with our asymptotes. Now, I would say this. If we're looking with our domain right here, our domain is going to be defined based on the basic function, right? Recall that we would say if y is simply equal to tangent of x, the domain was the set of all real numbers such that x does not equal n 2n plus 1 multiples of pi over 2, right? Odd multiples of pi over 2. And that meant that we would have vertical asymptotes at values like x equals negative pi over 2 and positive pi over 2 and 3 pi over 2. Well, let's just take on these main two, negative pi over 2 and positive pi over 2. What happens when we adjust the function right here? Well, here's what we have to know. The period of the function can be found in a way that's kind of similar to sine and cosine. The only difference is that with sine and cosine, right, our model was we divided 2 pi by b right here. Well, if we have a function y equals a times the tangent of b times x, our period is always found as pi divided by b. Okay, not 2 pi over b, right? Because the natural period of tangent is pi, so the period will be pi divided by b. So in this case, our period is going to be pi divided by 2. All right. Now, how does that affect us? Well, remember that our vertical asymptotes were at negative pi over 2 and positive pi over 2. So if that's the case, right, we could say, well, if we would normally put one cycle between, so I can erase this here, if we would normally put one cycle between negative pi over 2 and positive pi over 2 for the function tangent of x, we're going to take our argument 2x right here and put that between negative pi over 2 and positive pi over 2. So how do we isolate x? We'll multiply both sides by 1/2 and we get negative pi over 4 and positive pi over 4. And those are our new asymptotes within one cycle of the graph. So if I were to plot this, here's how I'm going to go. I'm going to have a vertical asymptote at negative pi over 4 and a vertical asymptote at positive pi over 4. Now the period of the function is pi over 2. And if you'll notice, the distance between our two vertical asymptotes at pi over 4 and negative pi over 4 is also pi over 2. So to get any other periods right here, to get any other vertical asymptotes, we're going to add pi again. So pi over 4 plus pi over 2, what is that? Well, that's 3 pi over 4 is our next vertical asymptote to the right. We would go to negative 3 pi over 4 for our next vertical asymptote to the left of negative pi over 4. But for right now, this is pretty good. So what do? In one interval, key points are always 1/4 of the period apart. And since our vertical asymptotes start at negative pi over 4 and end at positive pi over 4, we take 1/4 of our period apart, so we start adding increments of pi over 8. Actually, maybe an easier way to do that would be ask what's halfway between these two. Well, of course, 0 is right in the center. And we know that the tangent of 0 is 0. So this graph will pass through the origin. We're going to get a vertical asymptote at negative pi over 4 and a vertical asymptote at positive pi over 4, but what is directly between 0 and pi over 4? Well, that would be pi over 8. And to the left, by the way, it would be negative pi over 8. At these points, we are halfway through the period. Now, this is where we're going to use the number 2, because we've got a vertical stretch by a factor of 2, so instead of passing through 1, like it did in the tangent function before, it's going to go through negative 2 on the left and positive 2 on the right. So at pi over 8, that's a quarter period here, we're going to go through y equals 2, and at negative pi over 8, that's the quarter period to the left, we're going to go through negative 2. And so one cycle of our function will look similar to this. The next cycle over will repeat the same pattern. At the halfway mark, it'll pass through the origin. At the first quarter mark to the left of that, it's going to go through negative 2, and in the first quarter point after that, it's going to go through positive 2, and repeat that same pattern over again. So repeating this pattern twice right here, right, we notice that that is exactly what it's going to look like, and our period is just simply repeated over and over again as many times as we like.